At this point, I'll hand over to Catherine to take us through the first part of the Climate Toolbox tour.
Cool, thank you, MTS, and welcome everyone. It is very nice to see that many of you have not ever used the Climate Toolbox. The Climate Toolbox has been around since 2014 in various stages, and different tools have been added over the years, but even though it's almost 8 years old, there are still people who haven't seen it yet. So it's encouraging for me, because it means that when I participate in these webinars, more people are getting exposed to it, and that's, to me, one of the most important things, is to get the word out about this important resource. So the Climate Toolbox is shown here, and it's accessible on the web. So you can go to climatetoolbox.org, and that's where you can find it. And you can use any web browser to get there, preferably probably the Chrome browser, as that's how it's been developed, and then our tools are a little bit more stable on the Chrome browser. But they've also been shown to be kind of resilient across the other browsers too. So it's at climatetoolbox.org, and you can see here that the Climate Toolbox is basically, here's the landing page, and it's a collection of web tools for visualizing past and projected climate and hydrology of the contiguous USA. So we don't really have data for Alaska and Hawaii and Puerto Rico. And we don't have and for other countries in the world too. So we're focusing on the US, and it's actually the contiguous USA. And it's a collection of tools for addressing questions related to agriculture, climate, fire conditions, and water. Those are our 4 areas of application that we try to provide information, both real-time information and also future projection information, to help people to make decisions relating to these different applications. And then you can see here we have our tools, and each one of these boxes represents a different tool. So you can see that there are at least 20 different tools now, 21 different tools. And you can open up and explore these. Each one of these shows data summaries on maps, graphs, and dashboards. And you can get to those tools by clicking on this Launch Tool button. So for example, we can go to the Climate Mapper, which is our multi-purpose mapping tool, and we can click on that Launch Tool button, and it opens within the website. You still have this common black bar here, which connects you back to the Climate Toolbox, but this is actually the Climate Mapper tool. But you can still get back to the Climate Toolbox by clicking on the Climate Toolbox. You can go to other tools and use this as a navigation. You can also find out information about the data in the Climate Toolbox. We have a set of video introductions here, both to some individual tools and also to introduction to the toolbox. We have a set of case studies that we just did recently. MTS is actually one of our case studies. We have a set of tool summaries as well, and some other guidance information. These are 2-pager PDFs that just kind of summarize some of our toolbox, some of our more complicated tools and how they can be used. And we have a little bit of guidance information, including our workbook series, where the Climate Toolbox workbook can be used to help you to understand the structure of the Climate Toolbox, and to work through some worksheets to help you to create your own climate data story. And then you can always contact us too. Right now, the Climate Toolbox is being maintained by really just 2 people, me and Dr. Donna Botziglu at the University of Merced. And it is powered by NKN at the University of Idaho, and is also being supported by the Northwest RISA, NOAA RISA, which is CERC. Yep. Anyway, so that's kind of like high level. But anyway, the goal of the Climate Toolbox is really to make climate data accessible to a wide variety of people for decision making related to these 4 different applications. The data sets are scientifically sound. I'm going to talk about them in a second. They're used by climate researchers and published in peer-reviewed literature like the National Climate Assessments that recently came out. And the toolbox takes those data sets and tries to make them usable by anyone interested in learning how to use them by providing summary graphs, maps, and dashboards so that you can see summaries from the daily data or the monthly data sets. Okay, so the power of the toolbox really comes from the data. So we should talk about the data. There are lots of tools here too. But if you go under data, you can go under data overview, and you can see what the toolbox is mostly based on these data sets here. There are some other data sets that have been imported into the toolbox over the years that are not made by our group. These tools are really made by our group or a fellow collaborator. And when I say our group, I mean our Applied Climate Science Lab at University of California, Merced. So we have the past data and up to the real time is that we use in the Climate Toolbox is called the GridMet data set. And it's a gridded surface meteorological data from 1979 up until yesterday. And so yesterday is how we get that real-time climate data that we can actually use to do monitoring of what's going on over the US in different parts of the weather. It is available at it's a gridded data set, so it's available for all locations in the contiguous USA here at a 4-kilometer grid cell, which is a 2.5-mile grid cell. And that's kind of important because each grid cell is really representing kind of an average over the of weather over the grid cell. So if you are in the mountains where there's a lot of changing, or a place where there's a lot of changing topography or microclimates, you have to take that into consideration, that when you get a grid cell of data back, it's really representing the average over that 2.5-mile grid cell. And it might not reflect your exact location. It might, you may be in a microclimate that's different than the grid cell. Let's see, this GridMet data set is a composite. It has variables of temperature, precipitation, solar radiation, wind speed, specific and relative humidities. And then it also has some derived metrics for fire danger, such as that used for the National Fire Danger Rating System. And it is based on both ground station data, such as seen in the PRISM dataset, and also satellite observations of the ground from the reanalysis of NL-2. So that's just where it's kind of comes from. But this is daily data from 1979 up until yesterday. And this is primarily what all of our tools are based on. We also have some forecasts using the CFS model and for the next 30 days and the NMME for the next 7 months. I'm not really going to talk about that today. And then our future climate projection data about what MTS was just talking about. We have 20 different global climate models and 2 emission scenarios. So we have, I'm going to click this. So our future climate projection data first, we have 20 different global climate model outputs that are coming from CMIP 5. So that's what MTS was talking about. And we have 20 of those. And then from the future climate scenarios, CMIP 5 deals in representative concentration pathways, or RCPs. And in the toolbox, we have both RCP 4.5 and 8.5. And these scenarios, so 4.5 is the red here and 8.5 is the blue. This is going from 2000 to 2100. RCP 8.5 basically represents a pathway where you go from a radiative forcing of around 2 watts per meter squared up until 8.5 watts per meter squared in 2100. And MTS described a little bit of this, but basically this is a pathway to achieve 8.5 watts per meter squared by 2100. 4.5 represents the pathway to get to 4.5 watts per meter squared. And the 4.5 represents a future path where we have global mitigation and cooperation in trying to reduce our emissions. And RCP 8.5 is a higher emission scenario. It's a mission scenario really based on increased use of coal, which is not so realistic anymore because globally we're not relying on coal as much as we thought we were. So our true pathway is somewhere in between there, but the toolbox has both 4.5 and 8.5. And then with those outputs from the global climate models and the scenarios, we have a downscaling process that was applied to those, and it is a statistical downscaling using the the MACA approach, which removes biases and also increases the resolution of the model outputs. That's what I'm going to say about data. I feel like I'm going a little bit slow here. So the other thing I wanted to do while I'm talking about the toolbox is just to talk a little bit about the historical data. So in the tools that show historical data. So in the toolbox, you can see that the names of the tools, a lot of them have a prefix on them, like historical, or future. So the tools that have the historical in their name are really for tools for looking at past data, observations up until real-time data. And the tools that have the future in their name are really for looking at future projections. And there's also a forecast tool here. But that's just a general thing to kind of help you navigate the toolbox a little bit here. So first thing that the toolbox can do is it can help you to understand the variability of weather and climate just in your location. So first tool I wanted to look at was the historical climograph tool, and I'm just going to click this. And basically this tool gives you a graphical summary of historical average monthly temperature and precipitation for a location. We technically have 2 data sets here available, but basically this gives you a graph for a location. Here my location is actually in Moscow, Idaho. And the red here, the red line, it's giving a monthly view of the average temperature. And the red line is the average maximum temperature for the month, and the blue line is the average minimum temperature for the month. If you hover over the lines, you can see a little pop-up that'll tell you exact values. Temperature here is on, the scale is on the left. And then also there are bar graphs, these little gray bar graphs that tell you the average precipitation for those months in your location, and the scale for precipitation is on the right here. So you can see for my location, we have a typical kind of Mediterranean climate, somewhat, where we have high temperatures in the summertime here in the months of June and August, and we have our rainfall occurs in the winter time with very low rainfall, precipitation in the summertime. And so the climographs here really give you a signature of what climate looks like for your location in terms of temperature and precipitation. Yep, so that's kind of like the baseline of what we can expect from climate is an average over what's been seen for maybe like the last 30 years. Okay, one other tool that I wanted to go to was the historical climate tracker. Sorry, I didn't want to go so fast. So I'm also going to look at that one. And this one is a good tool for looking at the variability of climate in a region. So it shows a bar chart of historical summaries for climate variables. And you can see here what it does is I've got January maximum temperature for my location. And for each year from 1979, 1980, all the way up until 2022, it's showing what the maximum temperature, the average maximum daily temperature was for January. So you can, and that is, and the blue bars are where it is, the year was below average. The average is this line here, it's at 36.7, and the red bars are when we're above average. And so you can kind of see from this, one, you can see the average for your location, but then you can also see how the different years are varying and how much they're varying. Yeah, about the mean. So you can see those really low years. You can see just on average that you get Januaries that are within like 3 or 4 degrees Fahrenheit about your mean. Anyway, so I'm going to stop there as just that is just an introduction to the toolbox. I think I'm going to pass it back to MTS at this time. Does that sound good, MTS?
Yeah, well, Catherine, maybe you can say a little more about the different variables and the ability to plot different time scales here.
Yeah, I can do that. Okay, so in all of the tools, if you look at the, okay, so in the different, this is a sample tool here. So in all the tools, you can select a location to visualize for your data. So I'm looking at a point location of Moscow. So I'm really getting the grid cell back for Moscow. But you can also select a rectangular area to get area averages, or a US county or watershed. And then as I go down the options here, I can select a variable, and I can select a variable to show for the graph from all these different variables. So I've got temperature, humidity, radiation, wind speed, got some agricultural metrics of growing degree days, last spring freeze, length of the growing season, vapor pressure deficit, heating degree days and cooling degree days, and then a whole bunch of drought metrics. So that's just in this tool. Every tool has different variables, and that can be a little confusing. I'll get to it at some point. You can also change the units. You can also, and here I'm looking at January max temperature, but I can also choose a season. So I can look at March through May for springtime maximum temperature. So I can change some things about these different, in the options, I can change things for the season and for the variable to change on the fly to change the graph. Yeah. And maybe one last thing is back with the Climate Toolbox, MTS asked about variables a little bit. There is a Find Your Variable tool, which is a really great place to start if, I don't know, if you're maybe looking for something specific. It basically gives a list of variables that are in the toolbox somewhere. So for example, this is all the variables that are in the tool somewhere. We have different hydrology metrics, we have different fire danger metrics, even vegetation, leaf area index even. And so if I click one of these, like heating degree days, it's going to give me a list of tools that have heating degree days, and it might also, and so I can go to the heating degree, that tool, and it will have heating degree days visualized in there somewhere. And it can also give me a little bit of help to find it. It gives me a definition of it. But sometimes it can be a little bit hard to find that variable too. So anyway, so that's where I think that probably should stop. Maybe turn it back to you, MTS.
Great.
Okay.
Thanks a lot, Catherine. That was great.